Hey everyone, my name's Fomubad Borista Fondi, and today I am excited to share our work on a hybrid system for scholarly question answering using SPARQL queries and large language models. This is a joint work which was realized with Dr. Azanzi Jumekong. The work is going to follow this structure. We'll start with the introduction, then we'll do the existing solution and their limitations. Then we are going to talk about the solution which I've proposed, which is the hybrid system. Then we'll talk about its methodology, talk about the results, and we finally conclude. For the introduction, millions of papers are published each year, leading to information overload. As we can see, which is clearly stated or clearly outputted on the graph, you see that each year the number of publications always increase, which makes researchers to struggle to efficiently extract and synthesize information. For the existing solutions, we have platforms like Google Scholar, which is very efficient and helps us with finding papers and articles, but they are not very good in answering specific research questions. Same thing with semantic scholar. Then for the knowledge graphs, we also have very good knowledge graphs which are very precise but too technical for users, in the sense that we need to write out well specified queries to be able to query the good or the data which is needed. So all of these approaches, there's no single approach which effectively balances the precision and usability. For the proposed solution, which is a solution which I propose, we are struggling to combine SPARQL queries and LLMs, which is the SPARQL queries are going to retrieve structured data and the LLMs are going to work on the unstructured data. So this is going to help bridge the gap between the LLM, and which is a connectionist model, and the symbolic AI model, which is the SPARQL queries. It also helps very well in enhancing accuracy, which will be seen in the results. For the system architecture overview, it first starts by getting the user query. After getting the query, we execute it or try to retrieve this data by querying the DBLP or the same OpenAlex, and then later on, if if the query requires personal information about authors or any information which is unstructured, we pass it to the LLM for prediction, and we finally save the answer in a JSON or CSV format while waiting for evaluation. Here is the overall methodology of how it's done. For data processing and execution, we query the DBLP like I earlier explained after doing pre-processing. Pre-processing is the act of cleaning or deduplicating the data which has already been duplicated, considering the fact that we downloaded 3 different data sets from Hugging Face, and then if with these 3 data sets adding to the one of the QALD challenge which was gotten in 2024, we added that to it to be able to fine-tune our model. This will be further explained ahead. For the integration of LLMs, as I explained, LLMs came in to resolve the issue of the unstructured data, given the fact that we cannot use SPARQL queries to query the unstructured data, so we use the LLM to predict or to go through this unstructured data and read them, which will return to us the correct answer. So it helped very well, considering the fact that it enhanced the result of the SPARQL queries by providing contextual understanding for the scholarly queries. For the experimental evaluation, we used the dataset of the QALD challenge, considering the fact that that was the dataset which we had the ground truth, so we could construct our own evaluating system which we will use to evaluate the various models which we were fine-tuning. We evaluated it using the exact match and the F1 score, which measures the precision and the recall. For the results, it's going to be a table which will be in the next slide below, and which will talk about the various LLMs. It's a hybrid approach, as I earlier said. Here is the table which I was explaining, and you'll notice that there are 5 different LLMs which were fine-tuned or which were trained on the data set that we had, and the data set that we had with the ground truth value was the one of the scholarly question answer challenge of 2024, which we used. We see that for bed, the hybrid approach gave 45.2%, which was the result which we got in the other challenge. That was bed base squad 2 on case. For beta, it's a scenario which increased. Then for the beta, the same thing, which are all extensions of bed, T5 and Quen. But the highest performance we have gotten up to now is still Quen. Currently, some evaluations are still going on, which we hope that the results are going to increase. Here is a graph which shows from the table which I earlier explained, showing the various performance of the model on the data set which we had. So some of the key takeaways that we can get from this model, from this system, is the fact that when we fine-tuned LLMs on this scholarly question answering data set, it improves the performance. And then when we combine the fine-tuned LLM and the SPARQL query, you notice that it outperforms either the standalone model, which is a SPARQL query, or tested together with the LLM. For a more, and also this work is, like I earlier explained, is the more advanced methodology compared to the question answering challenge of 2024, which was realized by these authors. So to conclude, I would say this work takes a step forward in advancing scholarly question answering, and for our future work we are going to see how to further optimize the model, and also benchmark it against the state of art methods. So thank you for your time, and I'm happy to take any questions for those that have questions. Here's the question and answer session. Thanks for your keen attention.